And our first presenter is Jon Lindén from Ekkono. Are you there, Jon?
I'm here.
You're there. You're nodding as well. That's great.
Yeah,
so
absolutely.
why don't you share your screen and take it away?
Let's do that. Thank you, Magnus, and thank you all for joining. As Magnus said, my name is Jon Lindén, Jon Lindén in Swedish. I'm the CEO and co-founder of Ekkono Solutions, and we're all about IoT, smart IoT. And today, I'm going to take the opportunity to talk about something that I know that our customers really appreciate and find very interesting, which is the mass customization of products. And I know that that might sound like a contradiction, but I'll show you how it actually makes perfect sense. So let's start by kicking in the open door and talk about the fact that everything gets connected. And I argue that even though all products might be created equal, they are used and operated in very different ways. They run in different climates, they are run in different environments, they maybe even are used for different applications. But back to the top, what we're seeing is that everything is getting connected, from large down to small, from dumpers and excavators down to electrical drives, running shoes, even individual sensors. Some of you might have heard me say this before, because this is basically my mantra, that even though this is happening, I don't think that most people have really understood the real potential of IoT, because it's not in connecting things and collecting data. What I think is the real value of IoT is that you as a product OEM extend the relationship with your products out into the field, meaning that you can see how every individual product is being used, how it feels, you can help run it in an optimal way, you can upgrade it with new functionality, you can even sell it as a service. But all of this requires automation, and automation in IoT spells machine learning. Now, the traditional way of doing machine learning is that you collect data from many devices and you look for common denominators. We found early on that the remaining range from the Volvo, an electric car, is very different depending on if it runs in Kiruna or in San Francisco. The climate, the landscape, the road and traffic conditions have a big impact on what is the actual remaining range. Or the Alfa Laval heat exchangers, they have anywhere between 6 weeks and 5 years of maintenance cycles on these heat exchangers, because some might be deployed outdoor on ships, or some might be deployed indoor in clean food production. One is heating up oil while the next one is just cooling down water. So we decided to flip things around. When we talk about machine learning, we talk about edge machine learning, and actually running machine learning on board the products, doing individual learning. So yes, when I'm saying machine learning, we actually do machine learning, not just the inference at the edge. And by knowing how, where, when, and for what something is being used, that actually enables customization. And using edge machine learning for this enables automation of that self-learning and individual customization of how every product is being used. So that's why I'm talking about mass customization. Let me try and illustrate this with a few different examples. Let's start with a pump. A regular pump can be used for many different things. It can be used for pumping water in a skyscraper. It can be used in a wastewater facility. It can be used to pump beer in a brewery. Of course, the environments are very different, meaning that what is normal in one implementation is an anomaly in a different implementation. And by actually learning the context and training a machine learning model, there is a representation and a prediction of the normal behavior for that individual pump. You not only improve the maintenance of that pump, and you can proactively see when something might be breaking or something that needs attention in the pump. It also turns the pump into a smart sensor, because that means that you can see if a pipe is leaking or if it's getting clogged further up. And imagine when this applies to everything in a production chain, like the motor, the electrical drive, the compressor, the pump, the conveyor belt, then we can really start talking about Industry 4.0 and the ability to do smart manufacturing and smart production. We had another case that really got me happy earlier this year. And the reason is that we had no influence over this RFI that came out, but it really illustrates the challenges that we have been preaching and talking about for the last few years. It was Atlas Copco. This is for the IAS, so Industrial Automation Solutions. It's for adhesive solutions to the automotive industry. And what they said in summary was that, first of all, every car factory where they're being deployed is unique. They're all different. And they change over time. They might change the manufacturing or assembly line. The customers, the car OEMs, are reluctant to share data. And thus, Atlas Copco is lacking data to do analytics in the cloud or remotely. which means that the only place to deploy intelligence is at the edge in the factory, where they have an aggregate computational power equivalent to a Raspberry Pi. This is spot on perfect for what we do. We can actually apply all of this that I'm talking about into that kind of environment. So the cases that I'm talking about can basically be summarized into two different categories. We have maintenance and we have optimization. And what you want to do, as I'm keep arguing, is that you want to basically start with a generic product that you deploy. And rather than having everything prepared when you ship it and implement it, you start learning when you take it into production. So you learn in live environment what is unique about this environment. That is automatically incorporated into machine learning models since you are learning on site, which means that you actually learn the context and you do a customized model. And that can be used for the purpose of predicting when something needs attention. We always say the remaining is a very good word to explain what we're doing. The remaining range on the battery, the remaining useful life on a wear part, the remaining time to service, that is the kind of individual condition-based maintenance and even predictive maintenance you can do by using edge machine learning. And then you can take it one step further by assessing how can I take these insights, simulate different scenarios, trying out different settings for doing optimization. So then you can optimize that it runs in a more efficient way. So you might reduce fuel consumption or power consumption, that you actually reduce wear on the machinery, which means that you extend the life length. And this is something that we have applied to customers in a lot of different industries. We never bring the domain expertise. We are generalists. We're darn good when it comes to mathematics and embedded software, but we're not very good on gas turbines or electrical motors or pumps or whatever it might be. But our customers are very good at this, which is why we provide them a tool that enables them to do this implementation themselves. So we have customers in industrial equipment, in automotive, in energy, in even medtech. So I also wanted to give something to those of you who came here longing for some tech talk. And what we really do at Ekkono is an embedded edge machine learning software. We don't provide any sensors, no hardware, no connectivity, orchestration, or cloud services. Only edge machine learning. It's an embedded software library that you can run on virtually anything. So from large down to small. Scaling up is easy, by the way. Scaling down is really hard. But we can actually scale down to run not just on a gateway, but even a PLC or even a motor controller, or even down to the individual sensor. That's what we do. And the key to what I'm talking about in terms of mass customization and this individual learning is incremental learning. This means that rather than collecting data and doing batch training, you do continuous learning. And this is actually quite efficient because you do computation that is distributed over time, and you don't need to do all the reading and writing to disk or sending all the raw data to the cloud, which makes this a much more efficient approach. And it saves you time because you don't have to wait while collecting data, doing the training, and then doing deployment, but you can actually deploy and then start learning more and more and more over time. And it will also adapt to changes. So if something changes, you move it to a different location or you change a wear part, then it will automatically be incorporated. So all in all, this means that it's a very dynamic and efficient approach to machine learning. Our entire solution is actually designed bottoms up for the purpose of running at the edge and running onboard constrained devices. We can do everything in memory in one flow, from pipelining, where we're adding lags and sliding averages, to decorate the data sets, to inference, to training, to change and anomaly detection, sensitivity analysis, simulations, predictions with confidence using conformal predictions. All these different things are done in memory inline. And the latter is also used for the purpose of evaluating the models and then the insights that we generate on the fly in our machine learning solutions. So central to all of this and what we're doing is that we're making it simple to implement these self-learning predictive smart features. We want to democratize the use of this very advanced technology. And it's when it's used, not when you're doing all these POCs, that it really starts creating value. So once you've been crafting and developing an applicable machine learning model, when all of that is done, which can be done in Python and Jupyter Notebook environment, then it only takes a few lines of code to implement the solution in a real product environment, in a real firmware, and doing the distribution. So to wrap things up, what I've been talking about, and I've been all over the place, but the common theme is mass customization. And I argue that even though every product is created equal, they are used very different, and we need to customize to that. We need personalization also on the product side. We're used to it in our regular life when we do online shopping and everything else. And that actually means that products will become better and better and better over time. And this is automation of individual customization. And the key to all of this is edge machine learning and actually doing learning, not just doing inference, but doing learning. And one thing I want to send with you as a last word is don't wait. There are a lot of myths out there about how you need a lot of data and that it requires deep learning and you need cameras and sensors, which is not true. In every case that we work with, we have been using mundane, traditional sensors, and we have been able to apply the first level of intelligence with very limited data, only to learn more and more and more over time, which is a much better approach than waiting for 2 years, hoping that you're not going to collect the data that you need to make a smart product. There, I'm done, Magnus. Thanks.
Brilliant. Thank you. In a very good presentation and in good time as well. Good tempo. So if you have any questions for Jon, we have time to take one or two, and please put them in the chat. And meanwhile, Jon, can you briefly explain where you are as a company when it comes to financing and all of that, because we have a couple of investors I know in with us.
Sure. So we've been around for a while. I'm a serial entrepreneur. I met my co-founder, our CTO, when I did an assignment for the University of Borås back in 2015. We broke out the results of his research for over 7 years and started Ekkono in 2016. We had Valerud and Almi Invest join as investors in 2017. We have since been raising a total of 65 million, approximately, Swedish kroner. The last round in July, where we got a strategic investor in the shape of Etteplan, the Finnish service technology company, as an investor. They are also a partner that's doing the solutions for customers. So we've been around for a while. The pandemic was pretty devastating, to be honest. I think we lost 2 years. The tempo went down at customers when it came to product innovation, but we've been catching up since, and now we're going to catch up even faster.
Great. I don't see any questions from the audience, Jon, so I think we say thank you.